Previously, when we learned about inertia at rest, it made sense. Because if there is a rock at rest, it will stay at rest until an external force is applied on it. Now, this is fine. But what about inertia of motion? Will a moving ball keep moving forever? Because the law of inertia states that a body will persist its state of being at rest or moving uniformly straight forward until an external force is applied on it. So does this mean if I throw a ball, it will go on forever? Apparently not, because if that's the case, we'd be bumping into moving balls all the time. This happens because the ball is stopped by forces acting in the opposite direction on it. Like when a ball is rolling, there is a little friction acting in the opposite direction of the force that is stopping the ball. And though the effect of air resistance is very less, it does help in stopping the ball. Now, Galileo said all that is fine. The ball will stop because of friction or air resistance or other forces acting upon it. But he looked up at the sky and said, what about the planets? Why are they always moving? Why is the planet's speed always constant and not stopping? And then he understood there is nothing in space to actually stop these planets. There is no friction or air resistance in space to stop the planets. And hence the planets will go on forever in this constant speed. So Galileo understood what's the difference between inertia of motion and inertia at rest. You can see this motion of inertia when you're traveling in a car or a bus which is moving fastly and then stops suddenly. What happens? You tend to fall forward. This is because you tend to follow the motion forward, but then the brakes are applied which is in the opposite direction, and due to inertia of motion you tend to fall forwards. And that is the reason why drivers are advised to put on this seat belt. So what have we learnt in this video? We have seen about inertia at motion and how Galileo differentiated it from inertia at rest. So until next time, happy learning.